Hello everyone and welcome back. Now finally our audio should also be working. Um, let's actually also get you some desktop audio, although there's nothing going on. Okay. Great. So as you might have read in the title, today we definitely want to start programming our very own 3D game with, C++ and OpenGL. And in order to do that, of course, first things first, we're going to create a new GitHub repository. We're going to call that factory game. And well, we don't describe that, and we have it private. We're going to add the C++ template, and we're going to just use any random license. And then we're going to copy this HTTPS code, close this thing, and say file. File, open folder. Then we're going to go to documents. Let's call that just VS Code. Go inside. Let's choose that. And then, of course, we trust the authors. And then the first thing that we want to do is create a new terminal and say git clone, paste our link, hit enter, and it should be fine. So now inside our VS Code folder, we have our factory game folder. If we now want our factory game folder to be our main folder, of course, we're going to open VS Code, factory game, and then we're going to choose that. Perfect. Now we have the very basic setup. In order to make it work, we're just going to add, well, let's not add it here. Let's make a folder. Let's call that source. And then let's add our main.cpp there. Great. Then, well, we're just going to write a very basic hello world program. And then we're going to do our main. That's going to do our hello world. Great. And of course, we want to wait for user input so it doesn't close the window. Then let's just hit run start debugging, and we're going to use C++ and then the g++.exe. And then we should already see our output, well, our terminal. There we have the hello world. Great. So we wouldn't really need that at the moment, but it's just fine. And well, in order to make it all a little greater, we're going to edit this tasks.json and then later on add a launch.json. In order to do that, well, first of all, of course, let's check our tasks. What I don't really like is if it puts the version down in the bottom. Let's just leave it like that and get rid of that version down here. And be happy with that. Then we got our tasks. Of course, we want to build, first of all. This is correct. Well, let's actually replace double backslash with forward backslash here. Great. And then we have that out of the way. Let's actually get rid of this. We don't need that. And then let's get started. First of all, we want our std, our standard, to be C++17. Then, of course, we want to include our include folder, which we don't have yet, but well, that's a thing of no time. Workspace folder include. Then let's also add the lib. And well, what else are we gonna need? We are definitely gonna need the include folder for our Ming W64 setup. We got the L there, that's great. I think that's mostly it. We just have a few more things going on in the bottom then, but I'm just gonna paste them. basically it's just including well, the LGLFW3D the the LASIMP, and the LZ, the LOpenGL, and well, that kind of a stuff. So that's gonna work great. And then let's change this output here to be our workspace folder, and then slash factory game.exe. Perfect. Then let's change that to workspace folder as well for consistency. Build to perfect. Let's only copy the compiler down here. So that's a little greater. Perfect. And then if we hit run, we shouldn't be able to build that because we're missing all of the well, dependencies. Let's actually create a folder called lib, as well as a folder called, nope, not there, folder called include. And then I'm just gonna copy all of the things that we're gonna need. We're gonna copy these in here. Basically, that's just the GLAD, the GLFW, and the KHR platform.h, as well as an image loader for later on. But let's not get ahead of our time. Then let's add the libglfw3 to the lib. And well, where is it? The glad.c. I think we're missing one more library, and that's this DLL. And then, in theory at least, it should work. In function main, okay, I can't really tell what's the issue with that. If we ever hit that, well, let's actually move that to a new window. If that ever should be the case when you're programming, just use your Copilot and it's gonna be fine. Okay, it's giving me some weird answer that I don't get. Why is that though? Let's quickly see. Did I mess anything up in here? Could be the thing though. Okay, let's see. We got the standard. We got our include. We got the Ming W include. We got our workspace folder. Got the all of these libs. And we could include our main maybe. That could be a thing. Dash, no, it's not dash I, it's dollar workspace folder main. Perfect. Then in theory, don't want to run that, please. Then it's working again, I think. Yeah, we got our hello world there. Perfect. That's great. So as soon as we got that working, I would like to add another JSON file. Just for convenience, we're gonna add this launch.json. And well, of course, as always, gonna start with our version. We're gonna have a configuration. We're gonna, well, just copy some stuff that we're gonna need. Well, let's just copy the whole file. Okay, let's go through this real quick. First of all, well, we want to rename that maybe. Nope. Okay, so we're debugging an OpenGL project. We're gonna do the CPP DBG. It should launch. We have our exe here. That of course should be factory game.exe. got no args, we got false, we got workspace folder, external console is true, we got the me mode, we got the me debugger, pretty printing, and then that's fine. And if we now hit start, we should always run our main. That's great. Okay, so just in order to, well, get our very first window open, that's what we're gonna work on now. We're gonna need to include, first of all, I think it's first is always glad. Then is the include g of w. What's wrong with glad? Cannot open glad.glad.h. Why is that though? Isn't that included in our tasks? Let's check. We got our include folder, doesn't it? Well, that was stupid. Can we, or do we have to do it then? Don't think so. I've never done that. It should just work with our include workspace. Yeah, let's not waste, well, it's just working now, okay, never mind. And then of course we want to set all of these things up. So basically what we're gonna need to do first of all, of course, is load all of these things like, well, glfw and init them and all of these kinds of things. So let's leave that hello world there and let's do the rest in, oh, well, let's actually move that down and work in front of it. So first of all, we of course want to initialize glfw. So if glfw init has an error, print that error please. If not, we want to set our OpenGL version and profile. Then we got the window hint. That's not the correct thing here though. Let's do glfw samples. For anti-aliasing. Then we got the context version major, that's correct. Context version minor, correct. Let's align that. And then we got another window hint with the core profile. Okay, and then we can already create a window. Let's do that then. So we're gonna take the glfw window, call it window, and create a hello world window. If that doesn't work, let's say if it's null, then of course we want to be notified that it didn't work. And then next up, let's make the context currents. Yes, that's correct. Wow, this auto thing has gotten so great. It's crazy. Okay, then we want to load these functions using glad, and well, if the glad loader doesn't work, then of course we also want to be notified. So let's actually then set the viewport. Or do we want to do that already? Probably not. It should also work like this. Nope, it's not. Include glad is still an issue. Why? have any spelling mistakes, let's just ask our friend here. Didn't I copy this one? Don't we have source? Ah, okay. Well, glad.c is missing from, or the glad.c isn't included here, so that's an issue. And hopefully it's gonna work now. Nope, of course not. Ah, it's in the lib. Sorry, it's in the lib. Still not working. And there we got it. We have a typo there. Annoying. Ah, we're missing just a bracket there, or what? No, we completely failed here. Now it should be fine, I hope. Yeah, there we go. We got our very first window open. It's not really responding because, well, it doesn't work yet correctly. But if we enter anything here, it's gonna close. Great. Okay, so we made the context current and now we want to start rendering stuff. In order to render stuff, we could go the way and, well, just use basically an old OpenGL version, so we could draw basically triangle, that kind of stuff, straight to the window. Of course, we don't want to do that. So what we're gonna do first of all is create a new file called application.cpp. Then we're also gonna add an application.h. Well, okay, what's going on in the application? So first of all, I just want to clean off the main. So let's just extract that and put it in, well, let's do pragma once. And then let's do include application.h. And then let's include that. Include the glad before that. Perfect. And then we always had a third one, right? Nope. Okay. Then we're just going to start with our class application. We're going to have a run function. Great. And this run function then, what's the problem here? Ah, well, missing closing brackets. Perfect. And then in here, we want to do, well, also the pragma ones, or was that only the, nope, that's only the H. Yeah. Okay. Then let's add a run function in the, what's wrong here? Okay. Then let's work on the application.h instead here. Okay, and then in the application.cpp, let's do once again these includes. And then we can start working on implementing these functions. So first of all, as we know, we have this void, and we're gonna do the application double double and then run. And then we are just gonna paste everything that we ripped out of main. So let's quickly get that back, extract that again, and paste that here. Okay, and then of course we're also gonna need to include IO stream. Then of course we don't have these standard return values here. So we're just gonna use an empty return statement, as that's a void function. And then we see that, well, everything's fine again, and we should also be able to launch that again. Currently it wouldn't really do anything spectacular, so well, we should probably include the application. And then as soon as we have an application, hello, okay, okay, so now my audio is back up and running. Hopefully at least, yes it does. Okay, so if we run that now, we should get the same boring window as last time. Nope. Undefined reference to application. Of course, as always, if we run a new source file, we should add that to our tasks. So let's add application.cpp here, and we should be good to go. Nope. Yeah, okay, we don't have, well, a constructor yet, so let's just do application, do nothing, start. And then it's working again. Very, very nice. It doesn't do anything yet, but it says hello world on the top. That's already great. And then in here it also says hello world. Great, great, great. Okay, then let's have a look. First of all, in order to, well, print anything to the screen, or basically draw anything to the screen, we're gonna need our shaders. And those are gonna be a little complicated, but we're gonna try and make it easy for the start. So first of all, let's actually, well, do, what are we gonna do here? Well, let's actually create the main function of our application, basically our main loop. And then, well, that's a great idea. Clear the screen, swap the buffers, and poll for events. That's great. With that out of the way, let's do shaders next, I think. A very, very basic shader. Can we just do that at the top here? I think so. But let's ask our little helper here, just to show how great it has gotten. Please help me define basic vertex and fragment shaders. Okay, so we got those, and then we can just do this, copy that, and put that somewhere at the top here. So we got our shaders down, that's great. And well, then we can just use those to create the shader. Let's just let him do that. And it's gonna help us out with that. So we loaded all of that. We can load our two shaders, or basically compile them. And we have a shader program. We'll delete the shaders. And well, then we're just gonna do the triangle. Okay, so then let's have a look here. We, of course, as I said, first of all, vertex and fragment shader program, and clean up those. Then we can also just copy the triangle data. That should be fine. And well, let's copy all of the rest as well. Why doesn't it let me copy that? Okay, so what did we do here? We first of all have the vertex shader. We create it with this OpenGL function, and then we pass it the vertex shader source, and then we can compile the shader. Great, right? Then we do the same with the fragment shader, and then we create a shader program, and this shader program gets those vertex and fragment shaders. After that, we can delete them. Then we have the triangle data. So this is always the X, Y, and the Z. So we're currently just working with X, Y, with X and Y. We're just leaving the Z axis out. Then we're doing the VAOs and VBOs. So basically vertex arrays and buffers. And then next up, we have those attribute pointers. What they basically do is tell the program or the shader program where to look for, or how to understand the arguments it gets passed. So basically, right now we only have like the one argument, and so it doesn't really matter that much. But then we would have like 0 to 3. So 0, we have 3 vertices that we are pointing to. We have the float, we have a, well, that's just doesn't really matter. And then we have 3 times a float and 0 times void. So what happens then is that we enable this vertex attribute array, and then we're gonna just bind the buffers, and then we can do in the main loop just add the statement. Before we swap the buffers, of course, we want to use the shader program basically. But yeah, let's just call it use shader program, then use the shader program. Yeah, let's just do it with a lot of comments. And then finally, we're gonna draw the triangle. Then that should be it, but we're gonna need to do a little cleanup after this while loop. Cleaning or cleanup, fine. GL delete vertex erasers first, I think. Then the buffers, and then the program. Perfect. And well, we could also destroy the window, but we don't want to yet. So if everything goes to plan, yes, we see a triangle. It's not red yet, so let's work on that. Can't close it yet either. Can't even Alt F4 out of it. Alt F4. Okay, so in order to make it red, we can just change the color down here in the shader, and well, then everything that we're gonna draw to the screen is going to be red. But that's working, and that's great. Really love that. It's not like resizing the contents yet and anything, but it's working. Then let's just enter here, so we get out again. And well, as soon as we have done that, we can actually go ahead and reorganize a little bit. Because, well, we want to do this in the application. I think so, yes, but of course it would be nice if we could do all of this prep work somewhere else. So let's try and cut all of that out and say we want to do void application, and then let's just call that init glfw, and then did it just paste all my stuff there? Nope. Then in application, we of course need a void init glfw. And in the CPP, we'll have to have a look. So we can't create the window outside the run function apparently, or we'll need to pass it back. That's something we can do. We can do window, how was that again? glfw window. And then that's gonna return where's the window? Let's just return it in the end. Return window. Let's have a look at the application.h. Of course, that's gonna be instead a glfw window, and then let's make that pointer only. That's a pointer, right? How do we do those again? Do I need to put the star there? Nope, I don't think so. Yeah, just quick fix that for me, please. Then how do I get the reference from that? Can I just do that? Nope. Okay, then let's just ask the quick fix thing again. I want to turn window into a reference only, and I'm stupid. Yeah, tried that. Ah, because it's an incomplete class. Is that the thing? Let's just try and run that. Ah, well. Of course, we should then app.initglfw. Then let's also put down this here. I don't see the issue. That doesn't make any sense. Ah, okay, and of course we don't have the shader program here. So maybe that's also a stupid idea. Maybe we shouldn't do that then. Let's just get rid of that again. Okay, and it's working again. Great. So, well, what do we want to do after this little triangle? Basically, what we, of course, would like to do is create our terrain. But in order to create the terrain, that's probably a little early right now. What we are gonna need to do is basically set up some more stuff. Because, well, we want that to be organized. So let's think a little about how we are gonna set things up. So first of all, of course, at some point we're gonna have a world.cpp. And we're also gonna have a world manager that handles the world. Then we're also gonna have a chunk our world is going to be subdivided into chunks, and then we're going to have a cell.cpp. Forgot the CPP here and there. When we have those, well, we can basically we have kind of an idea of how we want to set things up later on. So that's going to be great already. In the application.run, we have all of this junk that we don't really need, and then we do, well, our main loop here. In this main loop, we of course want to always know the time difference from the last frame. So let's do that here. And then at some point we want to do the world draw, which is basically going to draw all objects in our world. So I think we can do that before we switch the buffers. Swap buffers. Yeah, it should be easily done here. So let's just do world draw. And I think we don't even need to pass anything right now. Maybe the shader would be nice to have. Let's do the shader program. Then before we start programming in world, chunk, and so on, let's also add the relevant headers, world.h, world manager.h, as well as chunk.h and cell.h. Okay, let's think about that. Our world is gonna hold all the vertices, right? Nope. We're gonna have a mesh for every chunk, just talking about the terrain now. So if we want to do a mesh per chunk, then, well, the world draw is gonna just loop through all the chunks it has and, well, then afterwards put that to, well, and in the chunks do all of the mesh calculations and draw and update and all of it. So that's gonna be great. But in order to get our world rendered then, we of course need to set it up first. Let's have a look at the world.h. We definitely want, well, or let's just start with the pragma ones. And then class, world. Yeah, don't know what that does. Doesn't need to be there, I think. And then of course we want to close these brackets. We don't need the, do we need the init? I don't think so. So let's get rid of that. We do need an update method. I like to stick with draw, and well, cleanup sounds great as well. So let's add that, and then let's think about the properties that the world is gonna have. So first of all, let's make those private then. And then of course we would want a world manager. Doesn't do anything yet. We don't have a world manager yet, so it doesn't really matter. But let's just get that. And then of course we want a vector of another vector. and then we're gonna do chunk. And that's gonna be our chunks array basically. And then of course we're gonna need the include vector, I think it's called. Then it would be nice to have the chunk in here. We can just include that, I think. Perfect. Then, of course, sorry, the world manager, but we're gonna do a forward declaration here. And then that should be fine. And what about our chunk? Is undefined because we didn't set up anything in the chunk, I guess. Okay, great. Well, first of all, of course, we need to get our world. So, world, new world, perfect. And then ideally we would want to update that and then draw it, but we don't do anything there yet, so no need to worry about that. Let's include the world here, or is that in forward declaration? I think we can just include it. Include the world, include the chunk. We don't need the chunk, I think, but we could deal with the world manager here as well. Somewhere we're gonna need to set that up. And that should be a capital M. Great. Then down here somewhere, outside the loop probably, we're gonna say world setup, create the world. Perfect. And then in here, shader program, not working. Well, okay, because we didn't set up this method correctly. Of course, we want a shader. How's that called again? In the draw method, it's a, well, we should first of all get our very own shader program, but we can just use the glue int one for now, I think. It's the wrong. That's the way you have to write it, okay. And then of course we're gonna need to add include. I think that's fine. And then we're still missing chunk, as chunk hasn't been done yet. We should of course deal with those in a second. So let's get the world.cpp and let's just copy what we need. Okay, so in here, first of all, of course, we're gonna include our world.h. Then we have our world constructor. Okay, and then, well, we got our void draw, void update, and void cleanup. But of course, we're gonna need to call that world. Okay, great. And then we have the, what's the issue here? I don't know what's the issue here, well, like that, like that, and like that. Okay, our update method, of course, gets the float delta time. I don't want to do anything here yet, though. Let's just pass that, as we definitely will need that. Float delta time. Great. Then let's go back to the CPP and work on the cleanup. And in the cleanup, of course, we want to get rid of all of our chunks, basically. And in our, well, in our constructor, we want to set our chunks. So let's see, our chunks should be, I think it's a standard vector again, as we said, chunks equals standard vector vector chunk, and then we're just going with 10 for now, or what? Yeah, let's just define int chunk size, no, int world size it is. And then let's copy that and put that here and here. Okay, great. So now everything's good except for the chunk, of course. So let's go to chunk and get that going. First of all, pragma once. And I don't think we need any of those right now. Let's just do class chunk. And close that off again. Definitely gonna need that shader program, so we're just gonna include we had this gl.gl in world, right? Don't even need, I think we need those, right? Yeah. Then we don't need that one, and we got a chunk with an X and a Y, that's great already. And then let's go to the chunk.cpp and just say, what do we need in here? Definitely gonna need the include chunk, of course. Okay, we have audio again. That's great. Well, what do we want to do here in chunk? First of all, let's do the constructor. And then let's do the update. And then I think it's draw and clean up. Yeah. Okay, then let's have a look. First of all, of course, we are gonna need another array, which is gonna be the cell array in the chunks. So let's go back to chunk.h and add that. Think we can just copy it from world. Let's do same thing here. Of course, include the vector and include the chunk. We are in chunk right now, so we don't need that. And then, of course, this is not going to be chunk, this is going to be cell. And then we are going to have this array of cells. Great. Then, of course, we need to include cell. Great. So we got that done. What about this one? chunk. We want to have int world x and world, let's call it world z. Okay, great. So we got our coordinates there of the chunk, and well, in the creation, we're just gonna say chunk, what does it say? No, world x equals x, world z equals, let's call that z as well. Can we just delete that then? Great. Great. And you're missing chunk as well. Yeah. Okay, and chunk is missing because cell is missing, right? So let's do the cell real quick. Let's do pragma once. And then Pavel, what's about VS Code? So great, isn't it? Right now, what am I coding? That's a great question. Well, first of all, we started with our application. So if we, well, probably we can't debug that right now because we got some errors. But well, we have our application, or the main is a little bigger. Basically, what we're just doing is creating an OpenGL environment where we want to do a factory game long term, but of course that's not going to be created in one day. So we got all of the OpenGL basic setup, then we have our world, which we're currently working on, and then we have the well, the main loop basically, where we draw the world, and then in the world, in the draw, that's where we're just gonna go for, well, these auto completions are just great. Let's just copy that though. And instead of deleting a chunk, let's create a chunk. And we're not just gonna create the chunk, we're gonna put the chunks inside of the array of the world right away, I think. So we already defined our x and z. That's, well, here, of course, we just want to chunk and then which one's which? Let's not do it this complicated. Let's just do for int x equals 0, x smaller, chunks dot size, no, not chunks dot size, but world size. And then we're just gonna do x plus plus. And then we're gonna do a similar thing inside here, int z equals 0, smaller than world size. And then in here we can do x and z. And then we can say, draw that please. Didn't we set that up as a property? Nope. Okay, then let's just say int world size. Great. So now we create a world. Let's just do the chunks. We got the chunks and we got the draw. So world seems to be pretty fine. Then the chunk. What's your problem? You need the cell. Okay, the chunk. Let's work on that then. When it's created, it has an X and a Z value. Let's also quickly create a int chunk size. And well, then in here, we can just do the same thing as we just did, basically. Or we could just go ahead and copy that from world. Put it in there and say chunk size instead. Copy that here as well. And then of course that's cells instead. Why isn't that working? Okay, well, because I'm stupid and we also need to put cell in there and in there. Great. Then the only issue is that we don't have the cells included. So let's do that this way. Or do we need to forward declarate that? No, I don't think so. It should be fine this way. Okay, so cell is the issue right now. Let's say cell has some public properties. We got an X and a Z for the creation. We got the update, we got the shader thing. Let's include the GLGL thing. Okay, and then let's also add a private cell size. Let's just make that 1. Great. Well, should be an int. Okay, and then in the cell CPP we can really start getting going. So let's say include chunk. No, we don't need that necessarily. Let's just say class cell. Nope, I'm stupid, sorry. We don't need to do that. We want to do cell double cell. And then that's not gonna be world X. Instead, it's gonna be chunk X. Or let's just call that local X. And local Z. Perfect. Then let's define them here. No, those can be actually ints. Okay. And then we need to think about the, well, the size basically. Are we just missing this? Nope. What's wrong with my thingy here? Well, I forgot to include this cell. How can you learn all of that? A great question. Just starting. Basically, C++, of course. Nice to have some basics. I'm missing some at some points. And then, of course, you also got this lovely Copilot thing going on in VS Code, which, of course, is great if you get stuck somewhere. And I could also, well, I can also think of some well, well-made tutorials that you could follow if you prefer that. I had that Learn OpenGL site that I was using at some point. Can I go to the chat myself as well? There we go. That's a great site to learn all of that. But of course, you can also just try and learn from me, but that's gonna be a little harder, I think, or for me it would be. Okay, so we got the cell in here, but it tells us it wasn't included. And that might be because we don't have that in the tasks yet. So we of course need to add all of those there. So let's just copy this line. Actually, one more time, I think. Then let's call that world manager chunk and cell. Okay, so now we only have this issue here left, right? Let's just start debugging and see. In chunk we got the error here, basically. And now that should work fine. Although, of course, it doesn't do anything new, because we don't draw anything yet. But you can see the red triangle again, which of course is nice, I guess. But it doesn't change anything, so let's try and add, well, this mesh to chunk. That's going to be huge if we get that done. So basically what we want to do for that is first of all define meshes, I would say. But let's just start getting going with the chunk.cpp, or let's check one more thing. World draw draws all the chunks. That's great. And in chunk, we don't want to draw all the cells because the cells won't have individual meshes, but instead we're gonna have one mesh per chunk, basically. So first of all, we should start by adding another function to chunk, and that's gonna be to generate the mesh. Void generate mesh. And then of course, oh well, that was the wrong one. In cell, no, in chunk.cpp, we create those cells. That's great. And in chunk.draw, we're gonna just go through for, let's just copy that. World.cpp, draw, copy, paste. That's of course chunk. And that's of course cells. That's of course chunk size. Like that. And then, well, the cells get drawn, but in the cells we don't draw anything yet, so it doesn't really matter. But let's actually add those functions real quick. Cell.draw, cell.update, as well as cell.cleanup. What's the issue with draw here? Why is it incompatible? Well. just a little something that I forgot here. Just like that, and then that should be fine again. Well, let's see. We want to first of all do the generate mesh thing now, I think. So let's generate the mesh. Ah, well, we just did it in chunk.h. So then let's do generate mesh here. Okay, and then let's see. First of all, of course, we're gonna have some vertices at some point, so we're gonna have to clear those. Then we're also gonna have some indices, I don't know how to pronounce that in English. And we're also gonna clear those. And then we're gonna do some new, basically some new vertices. In order to do that, there's a lot of OpenGL setup stuff involved, which I'm not gonna go into detail right now because it's just, well, I can go into details at some points. Okay, so the vertices are cleared, and then we just call every cell to basically call that draw methods, right? And then we're gonna delete that from here and deal with that later. This is of course just gonna be the chunk size here. Oh, it's chunk size and chunk size. And I would like to have that as x, x, and z, please. Great, and of course here as well. What's the issue here? Probably because the cell doesn't have a, well, it once, I don't know. Nice to have you around here. What were we up to right now? So we wanted to get the cell going again. The shader program is getting passed. That's correct, right? Should be. Need the well, we don't need the shader program for the cell because we're gonna do something a little different here. We instead want a chunk in there. Chunk. Well, it's this way, right? And then in cell.cpp, we of course need to do the same thing. And we don't want that. Thanks. And of course, we need to include the chunk. Then that should be fine as well. And then what we are gonna do basically is, what's wrong here? Also include the chunk. What we're gonna do instead of, well, drawing each cell individually, we're just gonna draw from within the chunk, but generate the vertices that we need basically in the cell, because the cell knows where it's at and then gives that info to the chunk. And it also knows which height it has, which, well, later on we're going to deal with terrain types and all of that kind of stuff. So the cell is going to know that kind of stuff. So in the chunk, let's see, we want first of all to create this method generate mesh. We want to create a mesh, of course, and this mesh is going to be well, consisting of all of these vertices. So that's why we have those at the top. I think we have them not yet added to the chunk though, the chunk.h. So that's why it's underlining those. So let's add those here. Perfect idea. Standard vector float vertices and an unsigned int for indices. Perfect. So with that out of the way, don't have those arrows anymore, and this is gonna go away soon too, I think. So let's go back to chunk, and then, well, we're just gonna do a lot of OpenGL buffer stuff. So let's just call that OpenGL buffer stuff. So basically, if we have the VAO, the vertices, then please GL delete those. Delete vertex arrays. If we have the buffers, then delete those. If we have the EBOs, delete that. Perfect. Okay, of course we don't know about VAO, VBO, and so on and so forth yet, but we're going to deal with that in a second. So basically, we can also do that just now. We have those unsigned ints, and we're just going to put them in chunk. Let's just put them here. Do we need to do them as those? I think we can also just do them as unsigned ints, right? Yeah. And then here we're just gonna need to... Can't we do that with our include GL type thing? Okay, it wants glad, I think. Yeah, it probably needs glad. Then let's just do glad. Then that should be fine. Perfect, and only cells is the issue. So what we're gonna do next is basically bind the generation of the vertex arrays, gen vertex arrays. Then we're gonna generate new buffers. Then we're gonna bind the vertex array. Great. We're gonna bind the buffer. We're gonna bind, or we're gonna buffer the data, yes, with the vertices, the size of the float, the vertices data, and yes, that's all good. Then let's bind the EBOs as well and buffer the data. And then we're gonna have position attribute pointers, and there we have the vertex attribute pointer, which we already saw for the, what was that, in the application, I think. Already had the, where was that? We have basically the same stuff going on here. We have VAOs, VBOs, okay, we added EBOs, and then we have the, well, the positional arguments, and then we're gonna need to enable that next. Enable vertex attribute array, and then, well, of course, later on we're gonna add more and more stuff to this, so we will add like normals and text coordinates and terrain types and all of that stuff. So we just basically let the shader know where to find which attribute, which it is going to need to calculate lighting and stuff like that, inside of the package that we pass from the CPU to the GPU, basically. So we don't want normals, we don't want text codes, we don't want terrain types yet. So we're just gonna need to GL bind vertex array with a 0. And then the index count, if we ever need that, is the indices.size. Okay, and the indices.clear is gonna happen up here. The index count, though, is that, I think we need to define that in chunk.h just to be sure. Let's just use another unsigned int, index count, perfect, great. And then in here, it's only the cells left that make problems. But we need one more thing before we can go on, and that is gonna be to add a quad to the chunk. So we're gonna say void chunk double double add quad. And then, well, we're gonna have a bunch of arguments and, well, the function body. Let's go back to chunk, add the void add quad. And we're gonna think about those arguments in a second. Basically, what we're gonna need is the positions of the corners of the cell. If we have those, we can simply add a quad, and that's gonna be rendered. So what we're gonna do first of all is basically add another library, which we don't have yet, I think. And that's gonna be GLM. I think we need that. We might not. I'm not so sure whether we're gonna need it. But let's just use the function. And then the things here, we want a vector const glm vec3. Let's call that p0 for the first position. Then we have p1, p2, and p3. That should be fine. We're not going to deal with UVs, texture coordinates, or anything like that. What? What is missing? It's not true. Let's see. Let's just accept that. It didn't do anything, right? What's going on here? We need to include the GLM probably. Basically a math class for OpenGL. Okay, let's see. In the chunk, we have that. What's going on here? Maybe this is gonna solve it. Yeah, that sounds great. And then of course that's incompatible with what we defined in chunk.h, but that shouldn't be an issue. We can just get that in there and be happy with that. So that's just gonna be the, well, glm something vec3, I think it is. I think we can just copy that. That's another great question, Roberto Boateng. Funny name, by the way. Um, just because of the German football player, not because the name is funny, sorry. So the thing is, if you use like, I don't know, Python or something like that, you can also implement OpenGL. But the very beautiful thing about OpenGL is, in combination with C++, is basically the performance that you can get out of that. It's just super performant, very good with that, and also just fun to code a well, it's also a high class language, but not as scripty as maybe Python or something like that. It's just good to have very precise control over data structures and that kind of stuff from time to time. Of course, it's always nice if you do a little coding project with Python or something like that, that you don't need to worry about data types and all that kind of stuff. But like, that's just a tiny bit of what probably people prefer in C++ OpenGL than in other possible things. Okay, so what's going on here? Declaration is not fine with the P0, P1, P2, P3. Why isn't it happy then? Or is it just old? Nope, it's actually a thing right now. We have this GLM here. Maybe we forgot to put the GLM here. Include GLM, GLM. Then that should be happy, right? Okay, no problem. And of course, I'm not an expert on all of that. I'm also just learning all the things here. Did some OpenGL projects in the past, but well, always more to learn, I think. Chunk has not been declared because chunk is currently kind of broken because, well, that's working now. And that's also not underlined anymore. So it's only the cell that's causing problems right now. Here it says chunk hasn't been defined. Could be a thing though that we need to forward declarate it because we might have an include circle there. We might. What about that add quad method that we were up to? Let's actually work on that now. So what we want to do is, I don't know, get some kind of a start indice. So let's do that unsigned in start indice and then divide that by 3 because we have 3 floats per vertice. So a vertice is a point, or a vertex is basically the singular, is one point in our 3D well, scene, whatever. And so one vertex consists of 3 floats, so we divide this by the size by 3, and then we have the start index. And then we want to basically just push back those vertices as it's suggesting here. So if we want to say we have our first corner, then we're gonna push back the p0.x, the p0.y, and the p0.z, if it lets me. Very good. So that's just the well, basically the positional argument. And I think we're just gonna put that like that. Positional argument. And that then goes to these buffers that we set up here. And when it's in the buffers, it's, well, getting printed or drawn in the next thing. Let's go on with the second corner, as well as the third corner and the fourth corner. I just love the auto completion feature of VS Code. It's gotten so amazingly great. Okay, and then we defined our corners. That doesn't do too much yet. We also need to define our triangle. So let's do first triangle and then just push back the start index and push back the start index +1 and push back the start index +2. And then have the second triangle and push back different things. There we have 2 and 3. And that's gonna form a quad, basically. And as soon as we have that quad alive, or this function, we can go into the cell thing and produce that. That's also a cell thing. So, or work with that add quad method. Because basically what we want to do in the draw method is, well, for now we're just gonna do the top face, and later on we're gonna subdivide all of that, where we basically then draw the sides and all of that. But for now we're just gonna do the top, and therefore, of course, later on we're gonna have height and so on. But that's basically kind of irrelevant right now. We're just gonna go with float x is the local x plus the chunk.worldx and the chunk size, and then the float for z as well. And then in chunk, of course, we defined the world x and world z as private. So let's just add the getters and setters for that. So let's do int get world x, get world z, perfect. Then back in cell, we can just instead use get world x, need some brackets, get world z, and also some brackets, of course. Great. So now we have basically the position of, or the x and z coordinate of our cell. We have our local, so the position in the chunk, and then we have the, that was stupid. Of course, we want not to multiply it with that. We want to multiply it with the world size, so the amounts of chunks there. No, the chunk size. So chunk dot get chunk size, I guess. Although we could also just make that public. Yeah, but let's just have a setter, getter for that. That's fine. And get chunk size, return chunk size. Very good. Then back in cell, we can just use get chunk size instead. Great. So now we really have the correct position, or x and z. And with that, we can then basically do our positions. And that's gonna be a glm vec3 positions array with 3 each, right? Is 3 correct here? Let me think about that. Then we have 9 positions. Yeah, let's just go with 2 by 2 for now, I think. Yeah, we're just gonna draw 1 quad for now. Then we're just gonna go and have a look. So our first position, I guess, can I draw here somewhere? Let's just use paint for that so I can visualize what I'm talking about. What's going on here? That changed a lot. That's the normal thing now. Looks crazy to me. So if we had our triangle, our quad, with, let's say, this diagonal subdivision, then we would have our our first thing here, second thing here. I can't write with the mouse, third and fourth. Or what can also happen is that 3 and 4 are the other way around. So now we're going, let's just go counterclockwise. So this is going to be the 4 and this is going to be the 3. And then instead of having this go this way, we're probably going to turn it around. So we have basically 1, 2, 3, the first triangle, and then 1, 3, 4, the second triangle. So that's kind of easy to have always the same orientation. If you draw it once, you don't forget it. So positions 0, 0 is going to be a GLM vec. And then of course it's going to be the X and the Z, and we're not going to care about the Y for now. But if that's the corner in the lower left, we're going to subtract the tile size. Yeah, I think cell size it is, divided by 2. And of course we're going to do that, or let's just do float half size. Yeah, that's kind of long. Yeah, doesn't matter. Let's just do it this way and subtract half size. And then the Z is gonna be also subtracted half size. Because of course we need to, if we say our base coordinate is the center, then of course we have to go down half and to the left by half. Okay. Then let's do more positions. The 0, 1 is probably gonna be the... Wait a second. Yeah, it should be the X that changes, and that should be my, yeah, plus. Oh, it already did that, great. And then we have that, minus half size. Yeah, well, I want to go all the way around, so we're starting with plus and then minus. And then after we got that done, we can just add a quad for every well, we don't really need to do that here because we currently only have one thing going on, so we can just say chunk.add quad, and then, in theory at least, it should draw one quad like at each cell, each cell's position. Chunk has not been declared. That's fake news, I would say. Let's see, that's cell.h. I think we have one of these circles here. So probably what I'm gonna do is just forward declare that. Hope that it's gonna work. In here we got the cell. Chunk.h has the cell.h. Cell.h has the forward declaration. What about the cell.cpp? Does it have? It has the chunk. Is that correct though? It should just work. Let's just run it and see what kind of output we'll get. Okay, abort. Then we can probably see that a little better. Okay, so request for member draw in chunk. Cells std vector cell. Ah, that's a thing. Chunk, 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 chunk. Maybe you meant the arrow. Yes, I did mean that. Yeah, I think that's just old. Let's just start debugging again. Okay, glad, chunk 3 it should be. Weird. Yeah, that can't be it. What's going on here? Let's run that with debugging again. Let's just put that into our helper, and while that's happening, I'm gonna get you some audio as well. I think at least. Okay. Although it's only these beeps if we have errors building. Okay, in chunk CPP it tells us to first include glad and then include GLM, which we do. And we shouldn't include GLD directly, it tells us, but we did do that somewhere. Not here. Not here. Let's instead try glad. And then let's just try again. Ah, we got another one of those here. Let's try again. Build finished, and we got our triangle, and that's it, because we probably didn't update our main application. We got the application dot run. We don't have a world yet. What? Ah, we got a world here. And we got the world draw. Okay, so that's good. Then in the world draw, we're gonna do the chunk draw. In the world init, we're creating chunks. So that's also great. In the chunk init, we're creating a cell array. In the chunk.draw, we don't do anything yet, and that's the issue. We are gonna need to do some stupid stuff in the chunk, and that is basically just binding the vertex arrays as soon as that chunk.draw gets called. So let's do gl bind vertex array with the VAOs. Nope, I don't want all of that. Thanks. We're just gonna GL draw elements triangles. Okay, so now the world draws the chunks, but we need to generate that mesh somewhere. And I think we do that before. No, the generate mesh is going to be in the world, no, in the chunk constructor, I think. Because after we basically initialize those cells, we can also just generate the mesh. Well, stupid me. Segmentation fault. That sounds interesting. Although it built successfully. Probably I didn't kill the last one. That's a thing. Oh, it's a segmentation fault. Never heard of that. Don't know what that means. But I think then we could also just... Don't really need that shader there, right? But what we'll definitely need to do in chunk is we currently only create that array. We don't create the cells within the array, as far as I'm concerned. So let's do for in chunk size cells I, j. Yeah, don't like that. Let's replace I with x, j with z. And just be happy with that. And then, yeah, why is that with new here? Do we need to do that? I don't think so. Why is that? Normally I'm pretty sure I didn't do that. Always, at least. Okay, but then we have some cells and we should be able to just go ahead and have that run. I hope that this separation issue thing just a second ago, no, segmentation fault. Okay, let's see. Don't have any output here. Can we actually maybe go back to application and get some debugging going on? Because basically what I would like to do is have this error callback set up. Therefore, we're just gonna take this little tiny function down here, the error callback, and what it basically does is it takes in the error, it takes in the description, and it prints that to the screen. And in order to make that happen when an error comes along our application's way, what we want to do is basically, so if it's in the graphics error in the graphics card with our shader, then we don't know about that. We can't really debug that, but what we can do is glfw set error callback. And with that, probably we're gonna have some more feedback. Abort error callback. Well, probably need to define it above and not below. Let's just do it up here then. Let's copy that again. That's not all I want. Okay, and then let's run that again. Do we get anything more? Nope. Okay, then let's just go ahead and ask our best friend here. I got a segmentation error at GL bind vertex array. what does that mean? Okay, in your code, generate was deleted or never created. Okay, that's interesting. It tells us not to generate the mesh here. What we could do, of course, then, but I don't think that that's going to be the problem. Let's actually see. We have this chunk, and basically, I would like to do it here. And the cells should be initialized. Don't really get what a segmentation error means. But what we could, of course, call is just delete that and go to world.h and get a void generate meshes function, and then we can call that in here, void world generate meshes. Perfect, and then we can call that where we create the world, basically. Then let's see. No segmentation error, but also no world drawn. Okay, then let's see. We draw the world here, so it should in theory work. Let's get rid of these here. Nope, only these. Okay, nothing's happening. Fine. Let's see. In our chunk.cpp, we're creating this, well, basically this VAO mesh thing. Huh. It could also just be that the triangle is, or the thing is facing. So it could be a thing that the quad is just facing away from us right now. So we might need to think about the positions real quick. That goes counterclockwise, as we said. And in chunk.add quad, we don't care about the counting, but we care about the positions, the indices here. So let's head back into our paint thing, which is ugly as hell. But it's gonna work. Or it's gonna help us make our program work. And well, I'm just gonna put that on a second screen. Nope, we're just gonna put that next to it. Okay, our first triangle is gonna be from 0 to 1 to 2 and then back to 1. So that should be fine. The second triangle is from the start index, so 0 plus 2, so 2 is here, and then plus 3. So 0 plus 3 is obviously 3, and that's here. So that goes this way, goes back to there. Let's just do it the other way around, basically, where we do 1, 2, 4. So that's 3. And then the other one would be 1, 2, 3. Okay. So hopefully now our screen isn't empty anymore, but it is. Too bad. Are we using the shader program for that? I think so. I think so. So look. Basically, we're doing that here inside the application, and we're using the shader program. The draw method here takes the shader and gets that to the chunks. And here in draw, we're not doing anything with that. That doesn't make any sense. And we also just copied this, right? So it shouldn't be an issue. Nope, we didn't copy that, yeah. Let's just ask our friend. If we don't know what's going on, that's always a good idea. So currently nothing is visible. How can you help me? Did we set a Y? Probably that might be an issue. Cell, we just set 0. That shouldn't be the problem. And the quad is, well, minus, minus, so bottom left, minus, plus, no, plus minus, so x to the right, and then up. But this just freaks me out a little bit. Can't we just do a thing like that for now? Then we just have 1, 2, and 3. That doesn't work here. And then of course here the same thing. Then I at least don't need to worry about the position in the array that gets weird here. But then we have minus minus, plus minus, plus plus, and minus plus. Yeah, that sounds great. Still doesn't work though. Maybe we should set a background color so we make sure that we also see stuff if it's getting rendered without color or whatever. So where could we do that? Maybe in the beginning, right? Didn't we already do that though? Clear color. Here, clear color. No, it's just GL clear. Then let's do GL clear color. So we just have a background color. Maybe that's gonna help. Okay, so that's working. That's great. Then let's just add camera so we can move around and see whether it's maybe somewhere we aren't looking. Might be a thing. So in order to do that, of course, we need a camera. We need that anyway, so it doesn't really matter. Let's say camera.h and camera.cpp. As always, when we add new files, let's go to our tasks, copy something, and nah, not this one. And then let's just call that camera. Okay, so we have the camera. Let's work on that. First of all, camera is gonna be the pragma ones as always. And then in here, we're just gonna, well, let's think about that. We definitely want our camera to feature public. Well, that's a lot. Didn't mean to get all of that. I want a constructor, of course. We don't really need update, I think. Don't want all of that. Set projection matrix sounds not wrong, but I think we don't need all of that. The view matrix might be a thing that we need that later on. Let's leave that, but projection matrix I don't care about. So let's just cut all of that out. Then we only have the constructor and our thing down there. Let's quickly include GLM. As well as the matrix transform. Then our camera, of course, will have a position, so that's also going to be GLM vec3 as always. Then the front as well as an up. We need that in order to calculate stuff later on. Don't worry about it right now. Then we have the yaw, whatever, jaw, the pitch, the Euler angles basically. Then we have float speed and sensitivity. That sounds great. And of course, this then goes here. What's wrong with this view matrix? What's your problem? Ah. Great, and a semicolon. Very good. Then we have that. Then we can continue with our camera, with the real camera basically. Not yet though, sorry. Forgot something. We also need, of course, a way to process keyboard and to process mouse movement. Let's just call that process mouse though. We got the delta time. Let's not do that. Let's give it a delta x, a float delta y, float delta z. No, basically the keyboard should just do the horizontal movement of the camera. So basically let's do delta z here instead, and then here do the delta time. So we have all of those, not delta z time, just delta time. Then we have an offset to x and y. Let's not deal with the process mouse yet, but that probably is a Z. Let's see about those things in the future though, and deal with the implementation of the camera class. So include camera.h, include the GLM stuff that we're gonna need, GLM think it's GTC something matrix transform. That's it. Yeah. Not that comma though. Okay, let's start with the constructor. Camera. Camera. And well, you're so good. That's gonna be it, I think, for the camera. We don't need to set up anything except these constants. And then next up, we're gonna do the view matrix real quick. GLM, get view matrix, auto completed. Great. What's your problem? Constant GLM mat4. Do I need to do constant here as well? Don't think that I need to do that here. Huh. Interesting. Let's copy the name just to make sure. It's mat4. Don't give, yeah, well, let's not worry about that. We're gonna deal with that later. Then let's do process keyboard first, because that's easy. And that's already it. So we have a velocity for our camera. This velocity is going to be the speed times the delta time. And then the position that we calculate from that velocity is our front times the delta z times the velocity. Is that correct? Yeah, I think so. And then we have the position is the normalized. Yeah, I think that's fine. So then let's do the process mouse real quick. Okay. Don't think we need that. What's that for? Ah, okay, yeah, you're doing it this way. That's also possible, of course. But what we could also just do is get those, put them here. Then we can get rid of all of that. Perfect. Then if the pitch is ever greater than 89, then it should be 89. And if it's below 89, it should be below minus 89, then it should be minus 89. That's great. Then we got our, basically our direction. Why did it call it front? It's fine for me, but okay. Then we had the yaw, the jaw, whatever, and the pitch, jaw, pitch, perfect. And then do we need to do that this way? Or can we just do this front? Okay, then let's think about this view matrix thing again. Maybe that's also old. Let's just run it. Camera 5.7. Why though? Got a constant GLM mat4. GLM mat4. Get view matrix, and the thing is constant. Ah, let's just try again without that. Still not working correctly. Okay, then let's do what we like to do. And just ask our companion here. Yeah, explain it to me, please. I don't get it. Ah, I think I found the issue. We don't need that here. Just want to pass the value, of course, when we're done calculating. Okay, okay, okay. And what's with camera here? Oh well, that's just old, I guess. And then we are in our Hello World thing, but we actually didn't hook up our camera yet to anything. So let's have a look where we're gonna do that. Of course, we want to do it in the application, I think, right? Would make the most sense, or we could also put it in the world. Yeah. Yeah, let's just leave it in the application for now. Where do we do the world? There. And let's also do a camera here. Let's say camera. Let's say camera.position, camera.front. And then let's see. Ah, well, we of course need to include that here. And then down here again, we have the camera, and then we somehow need to tell it that it should be the main camera, basically. But we didn't do anything to the viewport yet, I think. Oh, it's not the viewport, it's the... How's that called again? Maybe we should get an input manager for all of that as well. Yeah, we definitely need to get an input manager to that handles basically the mouse and the keyboard, and then we're gonna pass that to camera, process keyboard, and process mouse. That sounds good. So then let's quickly just add a new file, input manager.h, as well as input manager.cpp. In input manager.h, of course, we're going to do, as always, pragma once. And then we're going to include camera. And, well, we're also going to need glfw, I'm pretty sure. And then let's include the camera, as I said. And then let's do the input manager class. Well, that sounds right with... Do we even need to have a constructor? I don't think so. We're gonna need to process input, we're gonna need to mouse callback, and, well, we don't do scrolling yet. So this should be fine. Probably we should add last x. Let's make all of that static. Last x, static float, of course. Last z. Then we're gonna do static bool first mouse as well. And totally forgot that we need a reference to the camera. Okay, then let's... what's right here? Semicolon at the end. Always forget that. Then let's go on with the input manager.cpp. In there, first of all, include input manager. Probably we're gonna have some I/O to debug, so let's do I/O stream. And then let's do camera, input manager, null pointer. So we have a camera later on. Then we have the last X. Let's just do... What was our window size again? 800 by 600? Huh? Somewhere we do window, and after that should set that up. Ah, there, 800 and 600, so let's just do 400, half of it, and 300 for the last Z. First mouse is true until we set it to be not true. What's our, well, tasks? And let's do input manager there. Okay. Let's go back to input manager. Let's save that and then go back to input manager and do the process input, I think. So that's a little too much, but that down there could make sense. Let's have a look at that in a second. First of all, we want x 0.0f float z. Perfect. And then we have our window stuff here from glfw. We want to get glfw get current context key W pressed. So that's forward. So that's camera front times camera speed. We didn't set up camera speed anywhere, and we're gonna do that later. So let's just do, I don't know, +10. Or let's just do +1 for now. And then down here we... Wait a second. WS is back, so that's minus, that's great. And then here we're also just gonna do 1 and 1, I think. And that's also correct. A is x minus and D is x plus. Perfect. Then we should do camera process keyboard xz delta time. Perfect. And then we're only gonna do the mouse callback. Void input manager mouse callback. let's have a look at that. If first mouse, so if it's the first time the mouse is called, then we're gonna do last x is our current x position and last z is our current y position, or actually those positions that we, wait a second. If first mouse, which is true in the beginning, no, yeah, it's true in the beginning, then last, okay, so, okay, because we need the last x and last z here, we need to have a value in there, and that's why we use x and y from the current time step for the last time step if we don't have any there yet. So then we have an x offset and a y offset, and then we can just update these positions. So that should in theory be pretty much working already. And as we are calling the camera already, that might just work. Maybe we're gonna need to do some more steps though. Okay, we definitely need to set the mouse cursor to be vanished. So let's have a look at how we do that. First of all, let's go back to our application. We could also then do world cleanup and shader program. No, well, we don't have our own shader yet, so that's fine. And then we could have some glfw terminate. Okay, great. So then what's the issue actually? Well, can I just say shade a program? Question is where we want to do that. Probably in, still in this while loop here, okay. And then actually we should do that before we draw the world. So let's try something here. Can we just use our shader program to yeah, basically what I would like to do is, can we do shader program.use? Yes, okay. Do that one further up, but that's basically the same thing, I think. Then we want to set mat for view. Okay. Okay, that doesn't work as long as we don't have our own shader, I think. Yeah, that's not gonna work, right? Yeah, then let's just go ahead and quickly do our own shader. I don't care. Let's just call that simple shader. Should of course be simple shader dot h and then simple shader dot cpp. Okay, so it's gonna get a little more complicated right now. don't worry too much about that. So first of all, what we're gonna do is simple shader.h. We're just gonna, as always, pragma once, include glad, include glm, and include, do we need anything else here? I don't think so. We do. Include string. Basically, string is what we need. What's your issue? Ah, okay, fine. Class simple shader. Let's just go with that. And let's get rid of this thing. Get a semicolon here. And then let's see. We have our, we are gonna need our glued ID. And we have the simple shader constructor. Don't think we need the paths here. Then we're gonna have our use as well as our cleanup. And then down here we have set mat4. That's great. We have set int, great. Set vec3, we got that. Set float, we got that. Set vec4 is missing. Okay, then set bool we got. Okay, so that should in theory be all. Let's go back to simple shader CPP and have a look. First of course, we need to include our simple shader.h. We're gonna need a lot of stream includes, like this f stream, that one, that one. Yeah, and then let's go with that. What's wrong here? Ah, okay. Then let's just do the constructor first. Simple shader. And then in there, we want to do a few things. First of all, let's just leave that ID there. I don't really mind, but I think we can do that like further down then. So we need to work above that, basically. And if we have that, then we can just start with our strings. We got our vertex code, and that's gonna be load shader. That's just gonna be in, I don't know, let's put that in shaders. Yeah, sounds great. Sounds great. And let's do our shader sources as we did with our shaders in application. As you can see, where is it? Vertex shader source. Somewhere up there we did that. Ah, there. Now also constant char. So basically now what we do is mostly the same thing. We convert that to C strings, and then we can sooner or later pass that to create a shader. Like this and like that. Then I would like to do a quick check whether that was successful. So int success. Let's do, yeah, that sounds great, an info log, and that sounds also great. And then if success, shader info log. If not success, then of course we want to say that the shader vertex compilation failed. Else, we want to say that it compiled successfully. Then let's also say this is little ugly. Vertex shader compilation failed. And then let's just do something like shader debug and put that in front, so we know where that's coming from. And then basically what we're gonna do is, of course, do the same thing for our fragment shader, fragment shader, fragment shader, fragment, compile shader, and then we got the same thing here going on. Man, this auto completion has just gone crazy. It's really fucked up. Okay, we got our ID, then let's gl attach shader, gl attach fragment shader, link that program, and then check whether we got some linking issues. Shader program linking failed, shader program linked successfully, sounds great. Then afterwards, just as we did last time, we can do the gl delete shader, vertex shader, fragment shader. And then I think we're just fine. We're just gonna need to implement a few more methods, like for example this load shader. So let's do, that's not gonna be void, let's do static std string load shader. So if stream file shader file is shader file in file path, if shader file doesn't open, then shader debug failed to open shader file. Great. Return blah. The rest stream shader stream gets shader file.read buffer, and then return the shader stream. Perfect. And then we just need to implement a few more methods. What was that? Use and cleanup. Don't really need the cleanup yet, but doesn't matter. So void simple shader use is just gl use program ID. Yeah. Void simple shader cleanup, delete program ID, I guess. Yeah. And then we're gonna need to do all these small methods. Set bool. Just want to switch that up a little bit. Okay, and then let's do basically that for the rest. So void set int, great. Void set float, great. Void set vec3, perfect. Yeah, should definitely work. But we could also use a GLM value pointer here, I think. We'll have to see whether that's gonna work like that or not. Then let's do void simple shader set vec4. Did we miss any? mat4 is missing, I think. Okay, then let's check that again. So we got the set bool. There we just have the static cast int and our value. Then the set int just passes the value, I think, yes. The set vec, the set float then also just sets the value. The set vec3 think that's easier if we just use the GLM pointer thing. GLM value pointer value. Then next up we got the spec 4. That's going to be the same as thing. Right? Yeah. And then the matrix is also GLM, pretty sure. Okay, then let's quickly import that. Thanks. So we got our shader class done. That's a big step ahead. Then let's quickly get rid of these. Well, we should basically now store them. So let's first of all create a folder, shaders, and then let's create a vertex.glsl, I think it is, right? Yeah. Then let's also add a fragment.glsl. And then we can just paste those things into there, I think. What we have up here. That's the vertex. And that's the fragment. Then we can get rid of those. Where do we load those? Vertex shader, gone. Delete, also gone. Don't need that triangle anymore, so that can also go. And then don't have that much left in here. That's great though. That's great. So basically after the glad loader we should do one more thing, and that's the depth test. We didn't do that. GL enable depth test. And then GL viewport. GLFW set frame buffer size callback. And then let's do frame buffer size callback. Yeah, I want you to define that, please, because I'm lazy. Should be fine, I think. The callback should be fine, yeah. Okay. Where were we at? Here. Okay, then we're just gonna need to do some more faces, some more things. We of course don't want the backs of our quads to be drawn as well, so we're just gonna do the cull face as well as that, and the front face. Perfect, counterclockwise, just as we set up our drawing, so that's gonna work. So then we don't have to set up the VAOs, VBOs and that kind of stuff anymore, I think, because we do that in, where do we do that again? But we move that right to the chunk, I think. So let's just get rid of that. Okay, then we have our world and that kind of stuff, that's fine. Have our camera, but we also need our shader. Let's just call that shader. That's shorter. Shader point. What's that again? Don't think we need to do anything with that, right? Yeah, I think we're fine like this. Just need to import simple shader. Okay, what else do we have down here? That's just gonna be shader then. Yeah, then let's just do shader.id. That's gonna be shader. But let's go back up a little. I think we're missing maybe something. That should actually be fine. Okay, and then in the main loop, of course, we're gonna pass shader here. Yeah, we can also pass shader ID, I don't care. But what we basically want to do, of course, is process the input. So we got this input manager. So let's just use that, right? And do that before we draw the world, I guess. Yeah. So let's have a look again. After we use that shader, I don't think we need to do this. Let's just do input manager. Let's do that above though. Input manager process input and input manager mouse callback. And of course we also need to include those. Okay, now that we have processed that, let's get our camera view matrix. And the camera view matrix view is, did we define view already in application? Nope. Is that an application? No, I think we can just define it somewhere on the fly. Yeah, I think it's quite easy actually. So we just do the glm set mat4. No, it's glm mat4 what we want. Sorry. That's the view, and then let's do it this way and then say view equals camera get view matrix. And then we can say we want to use that shader. Let's move that below our comment. And then we can set the view, I think. Do we need to do that is the big question. Where's that error? Shader. But do we need to delete that down there? No, we're just gonna say shader cleanup. That should be fine. Did we define shader cleanup? Cleanup, gl delete program, yeah. So that should work. It should work. Let's just check. Let's just check. Okay. What have we got here? Simple shader cleanup. Simple shader cleanup. In application 115. But we imported simple shader. Simple shader use is also a problem. Don't have the shader in here, of course. That's such a common issue. Segmentation error again? Never had that before, and now twice in a day. Got this. Where's the speed? Camera. We have camera H speed. Yeah, but it's not defined. So maybe we should define that. I think I missed tiny little bit in application. So here we get the view matrix, but we also need the projection matrix, right? Or basically we don't use that yet, right? Let's just ask our buddy about this. Let's just run it once more and then ask our buddy about the segmentation error. Okay. Where's our chat? Huh? Okay, camera class looks fine. Usually means dereferencing a null or invalid pointer. Yeah, we could definitely do that if camera, but that's an application. What was that? Okay, camera equals camera. Maybe that's gonna help. But then I think I understand what a segmentation error is finally. No. Okay. Too bad. I don't understand it, apparently. Let's just ask again. And the chat has gone. Okay, change the declaration to match the implementation. That's old. That's like old, right? Can you see when... Yeah, that's old. Can you help me fix this segmentation fault? This one here is the problem. Or what? But what should be the problem with that? And it's also like exactly the same, right? That doesn't make any sense. Okay, so he deletes this one. Might be a thing. In that's a good idea. But still, it's not what I'm talking about, I think. Because it tells me it's in process keyboard, but of course that might be the thing here. Let's just rerun. Hope for the best. Still an issue. What could it be? Maybe I should Google what a segmentation fault in CPP means. Okay, it can be everything referencing anything that hasn't been set up yet. So let's check where we call process keyboard. Go to references is always good. Of course, we got that in process and the camera H, and there we also have this front position. My headset just turns off and on. Super annoying. Doesn't matter. So camera gets implemented in... no, I wanted to check input manager for... Was it... It was the process input, no? Or was it the process input of the camera? I think it was that. Yeah, process keyboard actually. Go to references and then let's go to input manager. Okay, and that let's go to where this is called. It's gonna be called here. So in application, but the camera should be defined by then. So that's something I don't get at all. Process input is also just this one thing, right? Yeah. Okay, so we set up the camera before you use it. That's a good thing, I would say. We need to set the camera for the input manager. I think that's something we missed. Probably that's also... we don't have a set camera function there. Then let's add that, I would say. Static void set camera cam. Great. And then an application that should go away, and that might just be what caused our segmentation fault, that we try to access a camera that hasn't been initialized yet. You definitely need to check the shaders. Okay, vertex shader doesn't work, fragment shader doesn't work. How can you compile successfully if you're not reading the file? Doesn't make sense. Okay, and let's check again. We got simple shader. Let's first of all check the... So it said failed to open. So let's check the path that we're giving. Shader, shader, shader. Or do we store them in here? We store them in here. Way easier. Vertex. Okay. Just called them vertex and fragment, not fragment shader and vertex shader. So maybe that's it. So we got a linked program. That's great. Okay, and then we need to make sure to, I don't know, set viewport or something like that. I don't know how it's called. But no, it's not the viewport. It's basically that our mouse isn't going anywhere. Let me check again where we can do that. Yeah, I think that should be this one. Where do we put that then? Let's just put it here. How did we call that again? Mouse underscore. Why do we do that? Consistency is key. Okay, so the mouse callback needs to have a... let's just leave that. But that basically disables our cursor. Oh, we got more. And of course in the input manager.h I messed that up, or no, it's here. And in the input.h we did that, and here, yeah, I think we made that static. Does that change anything? Do we need to put that static here as well? I don't think so. Let's just try and run. Could get built. Cursor is gone. Can't move around. Okay. Or we can, but we don't see anything. Let's ask our pilot here. Can we add checkered background? That would be really great, actually. Yeah, I don't want to do it this way though. Then I would prefer to just render quads. Can we still render our triangle? Oh, we deleted that. Never mind. Do we need to set up more stuff for the shader? That's the big question. So basically we did this shader use. Do we need to set any vegs? Think we need, well, we set that view matrix, don't we? No, we don't. Ah, here we do. But we don't do that in the beginning, basically. Or what we actually don't do is, after this setup here, we should also do some more things, I think. So we got this view matrix. And with that view matrix, I think we can just say shader set mat4 to get the view matrix in there. Maybe that's a thing. But might also be a problem what I did. So either our planes are just not getting drawn, or I don't know. Let's just ask our chat again. Or give me one more sec. Let's check some more stuff. Let's actually, before we do anything, add some statements that something's happening. Maybe in the input manager. because that's what we're calling. Um, yeah, let's just do it in the camera. And then do something like that. Okay, our camera position gets put out. That's great. Let's try again. And then if we move that left and right, front and back, will it change? Yeah, so the camera is actually moving. That's great. So we can just comment that out. And then let's just do std cout mouse offset. Okay, mouse offset doesn't seem to work, right? Where do we call process mouse? Probably from input manager, process mouse, mouse callback. Okay, where do we set X pause and Y pause? Go to references, application. Mouse callback, and we just put in 0, 0. That's of course stupid. We of course need to mouse callback. Huh. Yeah, where do we do this? Set input mode. There, then let's try this. Why doesn't that work again? And let's check again. Input manager also has that void. I don't know what's going on here. Cursor position callback, isn't that correct? Set cursor position callback. Don't really get what I did different this time. Okay. Let's not worry about this one then. Let's just comment that out for a second and deal with what we're looking for, the callback. Well, basically the mouse callback. How do we get that? From glfw, I think we can just get them. But I'll probably need to check how. Give me a second. Cursor position. Ah, okay. I think we need to do in input manager mouse callback. Nope, not there. In the actual callback, I think. Oh, that's the actual callback. Let's just try. And put this thing here. Or let's actually put it. Yeah, wait a second. In the application we could do that, right? We could just do this float like that. And if we do that, then we should be, huh? Yeah, let's just put them to 0 then. But this glf get cursor position wants that. Ah, it's double also. Yeah, then let's just do double. I don't mind. Double expose y pose. And it's working. So maybe our mouse callback will finally work. Just moving that around a little. Nope, not working yet. Ah, because I'm stupid. Okay, so the mouse offset is now working, and then let's try again whether we can actually see something. Trying to turn around here, but there's nothing there. So then let's just go through our world one by one, I would say. So in our application, we draw our world. First of all, of course, we create it by creating a new world and generating meshes. So new world, generating meshes, draw. Let's go to world then. First of all, creating a world sets the world size to 10. Chunks gets set up. In generate meshes, the chunks get created. Then and they also get, well, shouldn't we just do the chunk creation here? But not null point them, but create a chunk. Ah, okay, that of course needs to be just a pointer. Ah, and we also do that down there. Then let's just do null pointer everywhere and hope that that's gonna work. Okay, still not working. Fine for me though. So let's go back to the world. We said we do this first, then generate the meshes, and then draw. And drawing uses the chunks method and gives it the shader program. Drawing uses chunks method. There we got the draw. Add quad. Let's say perfect. Okay. And then I would also like to do that and yeah, and then let's just go ahead and watch the console basically. Okay, it's drawing quite a lot, I would say. Let's rerun that and basically kill it sooner so we can see the whole output. Okay, so basically it is drawing chunks at 10 or 10 by 10, 100 chunks per world. I would like to see the start of that output console, so I'm just gonna kill it as soon as the window gets up. Okay, it's adding quite a few quads. So then of course we should also check whether they also get the chunks also get drawn. Maybe it's a little confused because of my EBOs. Could be a thing. Let's try without. And then we get the segmentation fault. Ah, it might be that we're trying to access buffers that aren't there or something like that. Then let's just ask our master again. Hey there, can't see my meshes. Can you help me with that? Another thing we can do is move around a little further, because it might be that we just need to draw it from the other side or something like that. So if we go down, 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 and then look back up, don't see anything. Okay. Let's see, camera, where do we create you? Position 003 matches what he supposes. Ah, okay, that might be a thing as well, that I messed up the order here. Ah, okay, so we need to set the projection matrix. Okay, nice to know. Let's see, where do we do that? There, then let's just copy this. Okay. Let's see. Yeah, still nothing. Ah, okay. That should be done the other way around, or what? No, the projection should be done way earlier. Doesn't matter, I think. But these sets, mat, whatever, that could change something, I think. Let's just make sure that it's not because of that. Not because of that, definitely not. So then let's just delete that again. Can we disable dev testing and see something then? Wouldn't be a good sign if that would have done anything. Let's get these draw calls out again in chunk. Okay. Huh. Let's check the cell again. So our cell has that local value. It's got this global value where we add the local plus the chunk x times the chunk size. Makes sense to me. Then we have those positions. We divide them by 2, so we get half of our cell size, which is 0.5 then. Subtract that from x and so on. So these positions are fine. So it can't really be cell. Can't really be chunk, I would say. But this here, that's kind of weird, of course. If we call cell draw, that adds 1 quad. Are we doing something wrong here with the buffer, with the OpenGL stuff? Where's that? That's down here. It says that's fine. VAO, VBO. In your chunk constructor, tells us to do VAO, VBO, and EBO. Then let's check the shaders again, because those are old, right? Nope, we got this fragment. Yeah, please check my shaders as well. But we also did one thing, let's actually check that. Okay, we can also get rid of that mouse offset, I think. But I would like to have our camera position printed. He just knows what I'm thinking. Okay, what does he say? He's talking about the... Okay, so we don't have the model, we have the view and the projection. But I think I know how to do the model right quick. Yeah, that should be easy. think. Let's actually do the shader set down here. Then we also want the model. Okay, first of all, model. This is gonna be glm mat for 1f, perfect. Then we got the projection and projection. And we got view. Okay, and then let's get rid of that. Okay, and then let's go back to the shaders. We have this GL position is projection times view times vec for a pos. Okay, and then of course we need to add those uniforms. In the fragment shader, I don't think that we need to change anything. It's just gonna be red. Okay, still nothing. Okay. Okay, that made sense, but didn't change anything. Any other ideas? Application, GL enable, where do we do that? There. Test that. Hmm. Okay, then we also need to clear that. Let's make sure that we do that. GL clear color buffer bit, def buffer bit. That's what we're doing. Where does this index count come from in our chunk draw? Probably in our chunk H we have an index. Index count, yes. Where do we set that is the question. I think we increase it down here. Oh no. Ah, okay, that's fine. Let's find our viewport as well. Width and height. That matches. Or do we have another viewport? Nope. Should I just put that in there or what? After draw calls it said, and we're drawing. Ah, that might be an issue. We of course want to draw after setting up the shader. Ah, okay, we got an OpenGL error actually. That's good to know. Model view projection. Model view projection. Ah, that's bad. Still got the same issue though. Okay, then let's check that with the -1 for the setmat4. We did that in chunk, I think. Nope. World? Ah, no, it's shader, sorry. But those are set up in here. Nope. Set mat4. Okay, none of the uniform locations found. Ah, okay, just messed up the vertex shader because we need a model in there as well. Then GL position misses a semicolon. Let's see whether we still don't find any uniform locations. Okay, so those are all found. That's great. Then let's try again. Ah, I saw something. Okay, it seems as if our movement is still quite weird, especially with the mouse. Or something else is weird. Let's check the geometry. Um, uh, let's check the geometry. So basically we create our world at 0 height. Let's check our camera. Camera position. Shouldn't that be something like this instead? Because Y is the vertical axis. Something's just off here. Let's see again. Might it be that we should actually have something working together here? I don't know, let's ask him. So, world should be created at y equals 0. Our camera is at 5, but it's all acting up weirdly. So what can I do? Can we add lines on the outside of the quads just for debugging? I think he's gonna put some lines around and then we're just gonna see all of that better. What's wrong with you? Let's check that again. But why does it think that we need... Oh, that should be correct. But let's check that. What? Nope, it's chunk add quad. Okay, so we push back all of them, then we have 0, 1, 2 actually, and 2, 2, 3. No, 2, 3, 0. Yeah, then probably that was it, I guess. But probably not the whole time. We had some different major issues in the vertex shaders and that kind of stuff. Okay, then let's also redo the culling. That's disabled here. And we enable at here. Great. Then let's move this disabled thing further up. Okay. Then let's just add these indices, add chunk again. Then we'll probably need to add them in chunk.h. Okay, then you should be fine as well. Yes, perfect. Add a line EBO and upload data in your chunk generate meshes function. Generate meshes. Generate buffers, delete buffers. Ah, that's about EBO. Help me. Where do I put the second thing? But then let's see what we're doing here. We're just gonna add bool debug lines to chunk draw. Ah, we're not binding the buffer EBO. That might just be the thing, but let's not worry about that. Let's just do it this way. Ah, didn't copy that here. Okay, then let's go to chunk.h and fix the draw method. Bool debug lines. And then in world, where we're calling that, where is world.cpp, there we go. There we're just gonna set it to true for now. And maybe everything's gonna be a little more logical. Nope, of course not. Why would it? Could be so easy. Chunk. Let's go to chunk. Where do I get line EBO from? Ah, yeah, that was that thing, which I didn't know where to put. Generate mesh in chunk. Okay, so we got the VAO, VBO, EBO. That's correct. Bind vertex arrays is at the bottom. So this should be this, right? But we still don't have line EBO. Am I stupid? Or do we just set that once in chunk.h? Okay, just add that there as I thought. And try again. That's something that is kind of weird, I think. Okay, so I think it works. Let's actually, together with Copilot, let's change the color for the lines. I think the whole world is getting drawn, but it's then getting cut off because it's so big. And that way it seems to be a triangle, although it isn't. So let's quickly update our shaders. That's the fragment shader, and frag color should be color. And then we have another uniform. In your C++ draw, chunk draw, set color for filled triangles. And down there, GL uniform. Perfect. Then let's try again. Because before it was all red. How could we see any lines? Okay, so our world is looking Rather fine, I would say. But our movement is weird, because I always move in the direction that I'm looking at. So that's something we definitely need to fix. Let's go to input. Well, I think it's going to be in input manager, I think. Okay, I would like to use mouse for just looking around and keyboard to move around independently from mouse. Okay, so in Input Manager, process input, it tells us to do what we already do. Not exactly. Basically, it tells us to do z plus 1 instead, and z minus 1, and x, and x. I'm quite happy when that works now. Hello, there we go. Now movement is broken altogether. Does it need to be a float value to work? Try again. Yeah, that's not moving at all. Okay, process keyboard and camera. Yeah, velocity is already somewhere. Maybe here. No, we have speed here, but not velocity. Ah, that's what we already do, my friend. And there we do front. What's this thing here? Front times delta z times velocity, and then normalize. front, up, delta x, and velocity, right? Yeah. So didn't change anything here. And in the main loop, wait, we got an issue here. Okay, doesn't matter. And in application, we're gonna need to check. We do where's the delta time? Process input delta time gets 0. In the main loop, it gets zeroed. Yeah, that's stupid as hell. Mm. Okay, so that should handle the delta time that we need. Yeah, but it's going in the front direction. That's not what I meant. Okay, works, but not as intended. I want to move only horizontally with WASD and look around with mouse. The position or the direction should be direction of travel should be defined by the view, but the y value of the view should be ignored. Okay, let's see. Okay, camera, process keyboard. Okay, we want to go forward. GLM back front. Nope. Forward equals front. Missing D here. And then, of course, we want to say that forward y equals 0. And then normalize that. And then instead of front, we're gonna use for the right. Don't calculate right here. But we can do that. Ah, okay, there it tells us to do that. Okay, so then GLM back 3 right equals normalize cross forward up. And that should be it, right? We got the position front data Z and, well, that should be forward. And then down there we got position, doesn't need to be normalized anymore, but we can do right delta x times velocity. And then we should have the movement that we want. Of course, we'll need to implement jumping and, well, gravity and so on later on. But for gravity, we'll need bounding boxes, and so that's going to be a little complicated. I would like to eat something soon. Yeah, it seems to be working. Let's actually do in input manager something like 5. 4 is enough as well. A little more movement speed so we can really check. Then let's see again. Where is our thing? Doesn't matter where I look. If I go forward, just goes in the forward direction of the camera. So that's really great. So that means that we can actually get started with some more advanced stuff. But I think we're just gonna call it a day for today, as that was already quite long. 4 hours of uninterrupted programming and talking. Well, it was fun. Um, to the very few people that were here and are currently here right now, thanks a lot for watching, and well, enjoy a very nice rest of the evening. And next up, so the next time I think is gonna be either tomorrow or the day after, so Friday or Saturday, and either we're gonna add like textures, and I think that's what we're gonna do. We're gonna mainly work on the terrain and that kind of stuff, but maybe we're also gonna do a player first, so we can really walk around with some gravity and so on. We'll see about that, but terrain is of course one of the most important things, so we can build upon. Of course, we also want image loading and all of the model loading and so on to take place, so we can just import models from Blender straight away. But we aren't quite there yet, I think. As you saw today, I'm not too well prepared. I know a good basic, but there's way more to comprehend here. So, as I already said, thanks for watching. Have a great evening and see you next time. Bye.